seasons change. Our roads were lined with adventure. Mountains in the way couldn't keep us from the sea. Here we stand, open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
Now, hello everyone, and you should be able to hear me through all the music. We maybe fix the microphone a little so it's not in your field of view. It will be a little though. Can you still hear me. Let me know if my voice volume is basically enough, if you can hear me correctly. Apart from that, hello everyone, welcome to another of my live streams, and I guess today's topic is going to be a continuation of last topic, but before we get to that, my moderator today is Foxtrot Charlie, and you can find his nickname right here. Which means if you have any questions at any time directed to me, you actually have to ask Foxtrot Charlie. So write to this guy on YouTube chat, Discord, or our IRC, depending on where you actually are, since we have all three nowadays. And I guess if you're on our IRC, you can also write !Q, and then your question, I will also get that. Yeah, so that's that. Our topic is going to be basically, as I said, a continuation of what we done last week, which was, well, I was doing somewhat of a programming review slash as in code review, code quality review perhaps, and somewhat of a security review of more black box, a little white box of a web server with some custom programming language which I've written in 2004, so that was 15 years ago for my university for one of the classes. And yeah, we found quite a lot of security vulnerabilities, and yeah, I actually thought I wouldn't find so many, but I guess at least one of the vulnerabilities was something which was added to an operating system and which wasn't the case at the time I was writing the application for my operating system. And that was, you know, the one related to the NTFS alternative data streams, because there were no NTFS alternative data streams on FAT32 file systems. Anyway, so, but we found a lot of vulnerabilities, and we also looked a little bit at the code quality, and I actually wanted to look more at the code, but I guess I focused mostly on a black box review. So today we are going to do two things. I'm going to continue doing the code review, probably code quality review. I hope to go through at least one file, and that will be probably the second half of today's live stream. And the first half is going to be writing a fuzzer. I will take a part of a functionality of the web server. I will select one in a second, and I will write a fuzzing harness, so-called, for it, which is basically the interface between the application and the fuzzer. And then I will use, I guess, libfuzzer, which is a part of the Clang project, of the CLang, well, LLVM project actually, part of a Clang compiler, or CLang compiler, however you want to say it. I think I'm going to stick with CLang, though Clang has a nice ring to it. Anyway, so I'm going to use libfuzzer with an addition address sanitizer compiled in, and I will use that for fuzzing, as I said. And while the fuzzer is running, so this is going to be the first half, I will do a code quality review of one of the bigger and larger modules of the web server, well, actually one of the larger files, not really modules, but like source files of the web server. And yeah, so that's the plan for today, and I think we are going to have one more episode like this, like part 3, when I will focus on writing more fuzzers, which are going more in depth, because when it boils down, like, comes to fuzzing, right, it's a common mistake, well, partly a mistake, I would say it's a mistake. A common mistake is to basically like take the application, which takes something as an input parameter, tweak it a little so you can run it with AFL and like have it running, and that's it. And you wait for a week, and after a week you take a look at the results, if there are any file the bugs, and that's it. You're done. Well, this is only part of a story, and what I would want to show is basically how to iterate on fuzzing, how to make the fuzzing better, how to reach areas of code which you normally don't reach, and what tools you can use for that. So this is something I will probably focus on next week, and there will be no magic there. There will be just a set of iterative steps on which supposed to increase the quality of fuzzing, the code coverage, and so on. So we'll get there. Okay, I guess we can take a look at the standard announcements, then I can see if you have any questions, and then we can start in around, let's say 10 minutes, the actual live stream. Again, if you have any questions, you have to ask Foxtrot Charlie on our Discord, YouTube chat, or IRC, because, well, he actually passes the questions to me using telepathical ways, like, ooh, that question just suddenly appears in my head. That's exactly how it works. I apologize for a really technical description of that process. Cool. So, what do we have? We have Foxtrot Charlie's website. That would be foxtrotlabs.cc. So, thank you, Foxtrot, for being my moderator today and for helping me. And we can check all the new posts which Foxtrot is supposed to write someday, I guess. Yes. Then, as usual, I guess we might be getting tired of this, but we're creating this magazine, this Zine, where one article is exactly one page. It's going to be called Paged Out, and we are looking for authors. So there is this call for paper page, and it's pagedout.institute. So check it out. There are some example articles already, one by me, one by Q3K, KrzaQ from Dragon Sector. So yeah, I'm going to actually give you a link to it. Think if you can write something. We are looking for articles. You can actually, like, if you go to writing articles, you can see what topics, what are the example topics. And we would like stuff like demo scene, hacking, security hacking as in, electronics hacking, and hacking as in security hacking. Retro computers, like modern GPUs, FPGAs, software-defined radio, code goals, and like, think about the fun and hacky things you can do with like IT and electronics or radio, and this is basically what we are looking for, the fun, tricky things. Not the usual stuff. The usual stuff is cool too, but mostly like fun stuff. And there are some ideas for topics. These topics are like basically ideas of, like, they should give you a picture of what kind of topics we would love to have in our Zine. These aren't like hard requirements, but you have to write this article. No, nothing of a sort. Like, these are just examples. And there's also a section of like what we will probably not publish. For example, we might publish actually how to bake really good cookies. They have to be really good cookies, and we might publish like one article like that per issue. But yeah. So take a look, and then, oh, I do have a donation. Thank you. Moguntan Balaji Patabi. I'm sorry, I totally butchered your name, but thank you for the donation. Donations are always well welcome, and they help to pay for like my servers, for example. So thank you. And again, apologies for butchering your name. I am really bad with names. I'm sorry. On that note, or actually on an unrelated note, if you want to look at the source code of the thing which I'm going to review today, you have to go to my GitHub page, which would be like github.com/gunveil, and to repositories. And then you have to go to random stuff. And in random stuff, you will find Gosu, which is again my web server, which we will be continuing reviewing today. And I'm going to give you the link to it as well. Okay, and now we can take a look if there are any questions. So let me switch to this. Let me show the questions. You will see the questions here. And again, if you have any questions, you have to chat with Tell Foxtrot Charlie, because he is the person who passes me the questions. Okay, so first question. Why Golang puts func data in its assembly code when compiled with Go compiler, but not when done with GCC Go? Is it a special instruction? Not what is okay? I will answer your question by saying I have no idea what func data is. Let's see what func data is actually, because that might solve the riddle. Func data is that's fun data. Fun data. That's fine. That seems to be a place in how. Okay, I'm confused. How do you say Rumunia in English? I don't know. My mind is blank. I'm pretty sure I know. Romania. Oh, obviously. Okay, I'm sorry for that. So no, this is no. We are actually looking for func data. And func data seems to be something which is defined in Go runtime. Yeah, my underlining. So, no, that's not it. Fonts data. Okay. These defines and okay. That's weird. The file define IDs for PC data and func data, so maybe that's not it. But it really does put, what does it do? Like if we look at the Go Godbolt, it actually does put stuff here. Oh, that's weird. I actually have no idea what this might be. The rest of the instructions actually somewhat look like x86 assembly, but the PC data and func data, that's pretty weird. I don't know, is it like cross-compiled later? Like, is this assembler perhaps compiled then with some other thing to x86 assembly, and maybe that's a thing? I actually don't know. That's a really good question. Oh, there's let's see this. No. But it seems to be something really specific to Go. I never seen that before in x86 reverse engineering, so this might be highly related to Go. It's really interesting, but I don't think I can actually solve the riddle just now. Okay, well, where is this funcdata.h? Maybe we can find this. Okay, is this, yeah, is what we are looking for, so that doesn't work. Yeah, that's pretty weird. I have no idea what that is, and that is totally not an x86 instruction unless like no, but it only displays Go results, otherwise it would display ever. So I have no idea. This is a really good question, and I have no idea because I do not know Go too well, so I'm sorry, I will not be able to answer your question. But I might actually want to save that question for later. I'm quite curious now. Okay. Let's go to, maybe there are some questions which I should be able to answer. Why Python performances are so bad? What can be done in Python 4 to improve the performances? Okay, so it's like this. It's not really a problem of the language, it is a problem of implementation. And there are a lot of implementations of the Python language, the default one being CPython, the one implemented in C, and it suffers problems from, for example, global interpreter lock, which means that you cannot have CPU-bound multi-threading in Python. I mean, you can try, but it will not work. So, as in, it will not give you any performance advantages versus any other languages where that would work. And the way Python works actually is when you run a Python script, right? Then it gets compiled into Python bytecode. And the Python bytecode is very like, I don't remember, like 100 instructions or something like that. It's a quite high level bytecode, like similar to Java, VM, and so on. And then that is executed where each instruction is actually like, you know, for each instruction to be executed, you actually have to parse the next bytecode, parse the arguments, and then find the proper case for this instruction, basically like an emulator, and then run that instruction. And the instruction is actually really, it's like a typical emulator implementation where the VM is a really high level one, meaning it, for example, addition isn't simple code. It's not just adding to number. It's actually both types need to be determined, and if it's a string, then like some function related to string concatenation needs to be called. If it's integers, then another function needs to be called. If it's like one floating point and one integer, which is legal, then you have to do something else. So it's quite complicated code and quite a lot of it. And especially that Python has like things which are super complicated to implement, even though they're super simple to write in Python as one instruction or something like that. for example, taking a part of an array from a full array, right? Using the square brackets. So, and all of that needs to be, each time you, for example, do addition, all of the code which tries to determine the types, then goes to the proper function and executes it finally and saves it somewhere. All of this code needs to be executed. Now, what can be done to make it faster is you can actually usually implement a JIT, as in just-in-time compiler, because just-in-time compiler, one of the benefits it has for such high-level languages is that it can grab a piece of code and say that, usually this is like addition, like a function that does addition, and usually only integers are given to this function. So it creates a check and checks if, hey, if the types are integer, then just execute this one assembly line or two assembly line, and I mean like machine level code and not Python assembly. Otherwise, if the types differ, then go to the long route of something else. And that can speed the code really quite a lot. And I mean a lot, because JITs can observe the code and then make proper decisions based off what they've seen in the code. Obviously, if the decisions, like if what has been observed suddenly changes, then they need to recompile the piece of the code, and it cannot be like what they already have cannot be reused. But it's a normal thing in JITs. So that is what can be done. Now, that being said, if you, for example, use a different implementation of Python, for example, there is Jython, which is using Java VM, which has a really good JIT with Python. So it's basically Python is compiled into Java bytecode, and then that is executed on the Java VM typical virtual machine, which is really good. It has a really good just-in-time compilation as well. So yeah, if that happens, then if you use that, that's great. That being said, the implementations aren't really compatible with each other. Another thing which you can do is you can use, there are some, by the way, Python JITs with standard Python VM. I think PyPy is one of them, the PyPy. Then you can actually compile Python into C++. That doesn't speed up the code a lot, because you still need, for every instruction, you still need to determine the types and jump to the proper place. But there is some gain, I would say, to there is a little gain, at least, to the performance. Some is called, like the compiler is called nuitka. I can actually show you. If you go to nuitka, yeah, this is how you write it. Then you will find, oh, this is probably not the person. This is probably what I was looking for, I think. Yeah, Python compiler, which is written in Python, yeah. And it creates C++ code, which then you have to compile with C++ compiler. So it's, I guess, like some folks might call it a transpiler, but it's a compiler. And yeah, so that's basically it. So it's not really a problem of a language. It will, even with JIT, Python will never be as fast as C++, for example. Because in C++, due to a couple of rules in the standard, like as-if rule, the undefined behavior, C++ can be really strongly and aggressively optimized, and Python cannot be. But if a JIT would be added, if the global interpreter log in the default implementation would be fixed or actually dealt with, so it's no longer needed, then Python would suddenly get a lot of performance back. Okay, Dashin writes, C++ is evolving so much. We have a standard every 3 years, but the propaganda about it's not safe. It's not propaganda, it is not safe. It's not safe because of what I've just said. It's the same reason for it not being safe are the same reason for it being so fast. Basically, like, these are the same reasons. So it's a trade-off, basically. I believe it's safe. What do you think? No, it's not safe. Again, because there is one big reason, and that's the existence of the undefined behavior. If an undefined behavior exists in the language and it's unknown what will happen if a language reaches that undefined behavior, then things will go wrong. But the same undefined behavior allows the compiler to create faster and more efficient code. Because the compiler does not have to care about weird edge cases, which will never really happen. It just can generate code which works for the general purpose, like for the general case. And thanks to that, there are no ifs, no jumps, nothing. The code is really efficient, really fast. It doesn't support the edge cases, but that's up to the programmer to create code in such a way that the edge cases will never happen. And this is what undefined behavior gives us. On the other hand, these cases actually do happen because the programmers not always care about it. So the good thing is that the modern standards introduce more and more mechanics, like in the default library, which allow you to write the code which is actually secure and makes it harder for you to hit yourself in the foot, to shoot yourself in the foot, which is good, but it will not be as easy to write. It's just that it's not that you cannot write secure code in C++, it's just that it's really, really hard. You have to know the language really, really well. And yeah, that's it. But again, you can write secure code, totally, you can do it. But due to the existence of undefined behavior and due to the existence of the as-if rule and some other mechanisms, it is a language where it's pretty hard to write secure code. You have to have a lot of knowledge about the language. So again, it's not propaganda, it's basically the trade-off which was made when the language was... I don't know if that's really a trade-off which was made when the language was designed, but it's a trade-off that exists, like speed versus default security. And there are languages which are like also compiled to native codes but do not have undefined behavior, and they're a little bit slower than C++, but it's harder to actually do some language-specific exploitation there. You are the first... What? You are the first European. Read it right but slow. Oh, right. Oh, okay. I get it. Yeah, but I guess I read it slow. One thing which we could do on our planet, which would help a lot, is actually use the phonetic alphabet a little bit more. As in, you could actually, for example, put your name, and then you could put your name in the phonetic alphabet. I mean, I'm not saying like in this case, right? I'm saying like in general, for example, on business cards. I know some people do that, not a lot of people, and I know that because it's so unpopular, nobody can actually read the phonetic alphabet, and I cannot read the alphabet, but that would really like ease up these cases, and I would be able to, for example, read your name in a proper way-ish. Yeah, which I'm not sure I can do right now. But being said, there are also differences between languages where folks who are not speaking a given language do not hear and cannot make a given sound. And that's also pretty normal, so which also makes it harder with the names. Yeah. Names are complicated. Do look at GCC Go compiler at Godbolt. It doesn't work with PC or func data. Okay, I'm going to also note that. I guess we should start the live stream main topic really soon. Do you participate in civil war inside Google? I was not invited. Is there a civil war inside Google? Okay, I didn't know. Okay, and Foxtrot gave me a link. numba.pydata. Okay, and we can take a look. What's the link? numba.pydata.org is an open source JIT compiler which translates a subset of Python and NumPy code into fast machine code. Okay, that's pretty cool. That's really cool. That's good to know. And I actually should save this link. Thanks, Foxtrot. Good to know, and that I guess addresses one of the questions we had as well. So let me save it. Okay, perfect. I think there are no more questions, so we can start with today's topic. Again, today's topic is going to be fuzzing my web server, basically. So yeah, let's go with that. Actually, before we start, let's do 5 seconds of break. I need to run for water because my team will run out soon. Okay, apologies. Now we can start. So, this is the source code, and what are we going to fuzz? Again, as just as a reminder, this is a web server which has, well, we need to think what is the thread model of a web server in terms of fuzzing. It's pretty related to what I've said already last week, which would be, well, you do have this web server running on some machine and another machine can connect to it. So obviously you do have a HTTP protocol here, which is an obvious vector of attacks. And this is one thing which we can fuzz. This is what I fuzzed on the Polish live stream. And though up to some extent I didn't fuzz it fully. Then another scenario which I described last time is basically that we have a shared machine and one web server running, and then multiple users having their pages there. And this web server, as you might remember, has this funny little language called, well, gosu.gosu, I guess, which looks like server-side includes, which we did looked at excessively last week, so I'm not going to repeat that. And the idea would be that each user can create gosu files, and the gosu file is being parsed by the web server, and then the language is being executed. So I guess the assumption here is that there's a strong boundary between the users. These are like different users on the machines. One user cannot access the files of the second user, so these are like hard compartments, I guess. And but there is like one common server running, right? If one user could do something weird and could actually make the web server fetch a file from a different user, then that would be, I guess, like some kind of a privilege escalation, you might call it. But that's a pretty typical scenario with shared hostings with PHP servers. I know that PHP server shared hosting is like it starts to be a thing of the past. Like shared hostings are moving away. We are moving away from this model, and there are already multiple ways to secure, like the users, to basically put the users in different namespaces, for example, so there is no way one user can access another user's files. But in the past that was really a problem. But yeah, you could just like trick the server, bypass the open based restriction in PHP, and you could get access to another user's files. So this is basically the second thing, the second scenario, which is which we can fuzz. We can fuzz the language, or we can fuzz just the gosu, like the file itself, without, like, with a fuzzer which is dumb, which doesn't understand something like a language. It just flips the bits, and we can see if the parser, the initial part which is working with the language, will it fail, will it crash. So I would actually go for this, because on my Polish live streams I already handled this, and this is actually a really cool target for next week's live stream, where I would also go a step beyond what I did on my Polish live streams. So let's today attempt to fuzz the parser of the gosu language. And again, there are two levels here basically for the fuzzer, right? There is the file itself, the gosu file. So this is like the asdf.gosu. And then there's the actual language, where the fuzzer would have to understand the language. So we can mutate either just bytes in this and not understand the language, or we can create a grammatical fuzzer which actually can write code in this language and see if like teach it the language, actually like just hard code different expressions and create a generator which will create proper syntactically proper syntax files, and then feed them to the server. And here we would basically want to not really fuzz the parser, we would like to fuzz the implementation of the functions which are in the language. So that being said, let's start with the easy part, which is let's start with just fuzzing the parser as a opaque binary file, well, text file, but that doesn't really matter, which we do not know anything about the grammar. Let's just focus on the bytes. So to do that, we will actually have to prepare the harness for the fuzzer, which means we have to take the server and like basically grab part of the functionality from it, compile it as a standalone tool, which either takes like a file as an argument or has this magical fuzzer main function, which I will show you in a second, which basically gets the data from the fuzzer and has to do some processing, parse the code in this case from it. And once we have that, we have to compile it with the fuzzer in this case, because we will be using libfuzzer, and libfuzzer is actually attached at link time, at compilation time with the target. That's not true for AFL, for example. We might use AFL or like honk fuzz next week, but I guess let's not go there today. Let's stick with libfuzzer. And we also will need a method to detect any errors. And the standard way to do it in C or C++ is basically to look for crashes, or actually to look for to instrument the code in a way where it checks all the buffers, checks all the memory references if they hit the buffers, or maybe they hit between the buffers, or maybe they hit a buffer which has been already freed. And so basically a tool which implements additional checks for otherwise undefined behaviors. And that tool would be address sanitizer. I guess we already had an episode on how address sanitizer works exactly. I think that was on my English live streams. I know I did it on my live streams. I don't remember which ones. I'm pretty sure it was on my English live streams though. So yes, I'm going to use address sanitizer. So let's start with the first step, which would be to again grab the piece of the code, which is the parser for that Gosu, and like grab it from the take it from the web server and create a standalone tool for that, which is not really. We are basically like going to cut out all the things which are related to HTTP parsing, to the network sockets or whatever. We will just focus on actually the functionality which is related to parsing the Gosu file and perhaps executing that. Okay, what counts as a bug for me? I guess anything which address sanitizer detects, that would be a bug for me. And anything which address sanitizer does not detect but crashes the application. This is like in this scenario which I described, that would be I guess that would be a typical way you think about it. If I would, and this is the question from a Derbe supervisor, by the way, and if I would, for example, not use address sanitizer, I could use any other tool which looks for different kinds of bugs, like for example ubisan, which looks for undefined behaviors, which are not the one which address sanitizer looks for, I guess. Then we have msan, which is memory sanitizer. It also looks for some memory related bugs, which I guess asan also does. Then we have tsan, which looks for race conditions, which is a different class of bugs. And asan might detect some race conditions in multi-threaded code only if the race condition results in a type of a bug which asan would otherwise detect. But tsan can detect the actual race condition itself. So yeah, we can use various things, and once we detect the fault, we actually have to determine whether that is it a security vulnerability or is it just a bug, like a standard functional bug which you can crash the application maybe. which we can consider to be a breach of security boundary. Sorry, which we can consider to be a breach of security boundary, but you know, again, denial of service is like a pretty low bar as far as security vulnerabilities come, where you have like somewhere here a denial of service, and somewhere here you have actually like code execution on the machine, which gives you unlimited power with obviously the rights of a given thing which you compromised. So yeah, and just to be a little more precise, address sanitizer looks for bugs like buffer overflows, like use after freeze, write what wheres, read from wheres, and well, basically standard memory corruption things. It will not look for integer overflows, for example, where assigned integer overflows is undefined behavior according to the standard, so UBSAN might actually find it. But it's not a security bug indicator by itself. Usually, an integer overflow usually is not a vulnerability, but it usually, well, in some cases, it does lead into security vulnerabilities, like for example, buffer overflows. Because of an integer overflow, you might have a buffer which is too small, and then you might have a large copy to it, which would not happen if there would be no integer overflow. But yeah, that would still get detected by ASAN, well, not the first part, but the second part. Okay, so let's look at the source code. I guess we have to... There are two questions actually here. So a typical structure of like just the Python, which we discussed a second ago, is that there are two steps. There is one step where the one step is actually the compilation. And there is the second step, or actually parsing and then compilation actually. So there's like parsing, which leads into compilation, and then there's actually execution as a second step. So that would be the case in Python. In my code, I'm pretty sure I do not have any intermediate virtual machine stuff. I'm pretty sure my parsing leads straight into execution. This is the case, for example, like Windows batch scripts. That's usually the case for basic languages, for Bash as well. That's not the case for PHP or Python or Java. These always have this intermediate step of a virtual machine. It's a little bit more hidden in PHP than in other languages, but it is also works that way. So yeah, I basically what I was going after is that we might, if we are fuzzing the parser itself, we might not want to execute the code. Or if we are fuzzing only the parser and the compiler, we might not execute the code. Here we have a parser which goes directly into execution probably. There is like no intermediate form, so we might not have a choice here. We might actually have to fuzz both of them at the same time. So if we fuzz both of them at the same time, we can also think if we want to add any sorry, I'm going to start the server for a moment. If we want to add any functions to it, if we go here, then we have all the functions, and the functions are actually some of them, like for example link vault or project reset, I guess, or like basic stuff. These are taken from various extensions. So if we would want to fuzz the language itself, the implementation of that, we would also have to make sure that these plugins are loaded into the server. But since we are going to basically focus on the parser itself, which does, does tokenization, does the analysis of a text which is written, then we are going to ignore the plugins for now, and we will probably get back to them later on. I guess without the plugins there are still a couple of functions, but yeah, that should be fine. So what we, I guess, determined last time is that in main.c there was there was somewhere a switch case which depending on the file type did something, and we might want to take a look what is happening when we actually take the type gosu. So this is what's going to happen. It sets the type to sending whatever, I have no idea. Then it sends the header. Then it reads the file, I guess, into the buffer. I guess red in this case would be the file size, not a great variable name, and the pbuff is probably the file buffer. So I guess it reads the file. I would like to double check, but though there's a lot of code. Yeah, HTTP parse. Where's the... That's pretty weird. I'm actually wondering where's like fopen. Okay. Yeah, okay, so it opens the file here, then it gets the file size, and the file size is put into red, which is reused all around the place. Not the greatest design, but whatever. And we have type gosu, I guess. Yeah. So it reads the file, and then it calls this magical function, which is source parser parse. Then it takes like PRS, whatever this is. I have no idea what this is. pbuff, which is the file, the content. Red, which is the size of the file. Then env, which is and the environment, whatever that is. HTTP, which is I also don't know. And it also gets like DSDB output, which I guess this is if I remember correctly, this is basically a buffer which is auto-expanding when you add the data to it, and it's supposed to get the output. So what we will need, just looking at this, we need to basically rip out this function and all its dependencies from the source code, put it in another file, and make the harness. Now the harness format depends on the fuzzer, and in our case, if we look at libfuzzer, if we look at libfuzzer, then we have, this is the harness we need to construct basically. LLVM fuzzer test one input, it takes the data, then it takes the size of the data, and this is provided, this function is called by the fuzzer itself. So the fuzzer basically, each time it like does an iteration of a loop, of a fuzzing loop, it calls this function and it puts the data, it mutated into the data and the size into the size. And here we have to run the code, which in our case would be the src parser underscore parse function. Cool, so I guess we can get to it now. Okay, let's do it in this directory. I'm going to take a look if I have the proper Clang or like Clang installed. Let's see what version do I have. Okay, I have 7.0. That's not the newest. I think newest is like 9 or something, but that is good enough. We should be able to work with this. So let's create a fuzzer and let's call it gosu parser, or maybe parser fuzz.c. It is C language, so that's why it's C. Okay. And now I'm going to copy paste this here. Here we go. Now, yeah, do something interesting. This is what we have to do. And now we basically have to do whatever the main file does. We have to include probably most of this stuff, so I'm just going to copy it. I'm going to ignore Windows because I'm going to run my fuzzer on Linux. So this is Windows code, but I'm still going to run it on Linux. And if I remember correctly, this code actually could be run under Linux with minor changes. So yeah, whatever. And now let me look for that src parser. Okay, so we have to create a parser of some kind. Let's see where this parser is created. I don't know what this code does, by the way, because I've coded it 15 years ago. So I'm just reading the English words which are in the code. And like trying to reason based on that. So I'm trusting that this is actually like creating a parser of some kind. I don't know if it does, but I'm trusting that's what it does. Okay, it has like some conf and plug, but I need to resolve the dependencies. I'm basically going in a tree right now. So I have a main function and it has this dependency and this dependency I know of. So I go to this and I resolve the dependency for this, and it seems like it has 5 dependencies, and then each dependency has a limited number of dependencies again, and I'm going to need to satisfy all of them. And to satisfy all of them, I just basically need to copy some stuff and probably modify some stuff. So dependencies for the source parser, let me make this a little bit bigger for you folks, would be the conf and the plug, whatever this is. So, yeah, and it also, if it fails, then it fails. Okay. So if we go to conf, what is conf? Okay, it's null when we clean, and it's open config, and it opens some config. And if the config is not opened correctly, then it actually, what's the config? It's just like this file. So it takes a string. I'm going to substitute it with a string. I'm actually going to use a different coding convention. Now, the question is, do we really need a config? Does this source parser thing, no, it's not defined here. So let me maybe open another tab with this code. Let's go here and let's see where the parser is actually located. Script parser was going to be it. And let's go here. I'm not going to copy any code from here because I'm going to include this file directly, but what I want to know is the config actually used for anything? Is the CFG here used? It says no config and it actually returns, but that doesn't mean it's being used. So, okay, it sets the parser config, and that's all what's happening. So I guess the parser is using the config somewhere later. So new parser config, okay. Okay, cool. Now the question is, if I have this field which is called config, let's go to the header file for a second. Yeah, the head, because I'm using this, I'm actually pretending this is a private class. It's obviously C, so there are no classes, but I can pretend as a C programmer, but it is a class. Okay, so this is actually the definition of this structure, and there is the CFG. And it is being assigned here, but it's not being used anywhere. If it's not being used anywhere, then I probably don't care about it. But it cannot be null anyway, so maybe I will just give it the config. I mean, I don't care too much, it can read the config for all I care. I can also read the config only once if that's possible, because reading any file from the disk will actually slow the fuzzing down, and you probably don't want to do it. Instead, you'd prefer to do it once. I'm not sure this is an option in the fuzzer. I think it is, but I don't remember how do you do it. Okay, there are some examples. Advanced examples. Okay. Startup initialization, this is it. Okay, so yeah, this is the method which they are proposing to use. Okay, we can do that. So let's do this, and let's create here. Oh, I cannot use bool. Well, I can use bool because this is C, and C you can do include std bool, and you can use bool. It's actually part of a standard, so it's not like I'm making up stuff as I go, as I usually do anyway. So I can create this do initialization, which is a bool, and it should return true. I guess you folks know that this in C is actually different than in C++. In C++, this is the same as void. In C, it's more close to this. You cannot write this in C, but I guess you get the meaning. This means that you can put any arguments here, a lot of arguments, and it will be fine. So I'm actually going to switch this to void to indicate that this doesn't really take any arguments. Okay, now, yeah, so for the parser, I'm going to initialize the parser each time, but the config thing, I'm going to actually initialize it only once. I'm going to read it only once. I probably can live without it, but I still want to do it. And I have to create this as a global variable. So yeah, this is a static variable, which means that this function is going to be called only once when the function is first entered. This initialization is going to be called. Furthermore, this isn't supposed to work in C, so we will see what happens, and we might have to work around it a little bit. But yeah, even if it doesn't work, if the compiler says, "Hey, in C, this syntax is actually illegal," I will just do a semicolon here, and I will check if initialized has already been set to true. If not, then I would call the function and set it to true in an if, which will work in a similar way, not identical way, because this is actually protected by a mutex, and which means it's actually thread safe, where my code would not be thread safe unless I would make it thread safe, which is a lot of more code. So I hope to avoid it. I hope to get away with this, especially that I'm pretty sure there might be some GCC extension to allow me to do that, like GCC language extension. Okay, so I do this. I actually hope that the config loads correctly, and afterwards I need plug, whatever plug is. What is plug? Okay, plug is related to plugins, and the plug means probably that the plugins are being loaded. I do not care about plugins, I guess, too much, but let me create it here. Plug equals to plugins, probably plugins open, right? Yeah, plugins open. I do need to pass it the config, because the config contains a list of the plugins, and I might actually create another config like fuzz, which will be pretty limited in terms of what it actually has. And why does plugin open have like this Gosu script thing here? Why does it even have an argument? I'm confused. Show me. Open section. Oh! Creates a new plugin. Handler loads the plugin, and it's a section. That doesn't explain anything. Oh, sorry, that's the wrong file. What is the section used for? If there is no section, then go away. Otherwise, copy the section name into plugin section. Alright, I don't know why. Oh, okay, now I get it. It's actually like a section in the config which specifies the plugins. So yeah, so I have to probably leave this as like Gosu script. Let's look at the config itself. I'm pretty sure I have it somewhere here. So let me copy the config, and yeah, this is the config, and yeah, this is, oh, it just shows where the plugins, and these are the plugins which are going to be loaded. So I can modify this already, because I'm not going to be using the config for anything else. I could remove most of it, but on the other hand, I do not have to remove most of it, so I can leave this as is. I don't really care about it, because there will be no, I hope it works without any plugins. I hope it does. I wonder what will happen if I do this. Maybe it will just crash and it will be unhappy that I do not have any plugins. We will test it in a second. For now, I'm going to leave it empty. File names, spices, and tabs are not supported. That's fine, whatever. Okay, so the plugins are loaded, hopefully. And then, okay, so this is satisfied now. And now I have to look for src parser for the invocation, which we looked at, which is this. Okay, so now we have PRS is fulfilled. This is our data actually. I guess the pbuff is a little different type. What type are you, pbuff? It's a char pointer, so we need to cast into char pointer our data. Then we have ret. Ret type is int. Okay, so we do int of size. This is what we will feed to it. Env, we do not have env. We do not have HTTP. We do not have this. So these are the three dependencies which we have to satisfy as well. What is env? What are you env? Env is a list. Oh, I know. It's a list of environment variables, as in actually variables of which are in the state of the application. So we. Oh, and same with HTTP fields. So we might actually want to create both of it, and ideally we might want to fill out both of them, but let's not do that yet. Okay, how is env created? Oh my. Apologies. Now, var list create and var list create. Okay, perfect. So this is going to be pretty easy. This var list is just like a map in C++. You can think of it as a map from C++ or like a dictionary. Okay. This is quite weird. Why is it like this size and not related to the file size? I don't know why this is the case. That's pretty weird. Oh, there's still, it seems there's a size limit. So the question is, what do we do if we get a bigger file? By default, by default, libfuzzer doesn't create large files. It focuses on having the files as small as possible, the same way AFL does. So we can ignore it, the problem. Yeah, this doesn't have to be perfect code, it just has to work. If it crashes for reasons related to our code, then we can fix the code. But not yet. So okay, we have this created, and now we need this to create the output in this funny... Oh wait, this is actually calling a function? Wow, why does it call a function? Why do you call a function? Void output. Oh, it's this kind of output procedure. Okay, I can live with that. Let's just create this like output procedure, and it will do this, which is exactly nothing, which is perfect. And we call it proc. Okay, I think we have it fully satisfied now, but since we expect this code to be run a lot of times, we actually should handle proper freeing of memory. Which means we do have to do source parser close on the PRS. We have to do var list destroy or something like that. Oh, how is it called? Var list destroy, yeah, okay. So let's do var list. Oh, we can actually copy this piece of code, which is perfect. Okay. Do we need to destroy anything else? We do not destroy the config because that's pretty important. We did destroy already the parser. Do we destroy anything else? Not this plug. No, because plugins are loaded only once, so we do not destroy plugins as well. If the language would have the ability to change the config on the fly, then we might actually load this each time, but otherwise it's not really needed. So I think this is actually it. And by this being actually it, I mean we will still have to fight with compiling it and linking it with all the proper things. I actually created a makefile which is not called the makefile, it's called fuzzermk. So I'm going to use that, and okay. And let's yeah, oh whatever, let's just do this. clang, and then in clang we do our parser fuzz and we might want some parameters. Wall w extra, wait. So this is for warnings, then this, and then we need to actually put in the, compile it with address sanitizer, compile it with the fuzzer. So fsanitize address and fuzzer. Okay. We might want to compile it with GDB symbols for easier debugging. And we need stuff now, all the stuff which is related to the files which we are, like the dependencies from here. We need this file, I'm pretty sure we need it. We need, I'm not sure about the string extension, we probably need this thing. We need plugins. We don't need net, we don't need main. I'm not sure if we need linked list. We probably need a linked list. We need this is for the, oh wait, no, the output, we don't actually need the output. So we probably don't need the linked list either, but the var list is actually a linked list, so let's keep it. We need the config, I'm pretty sure we need the config. Okay, so let's try with this, and let's see if we can actually get it to compile. Yeah, make -f, and wait, where am I? That's fine. No, where am I? Yeah, I'm fine. That's fine. Yeah, this is a different episode, so don't worry about it, because I had the code already unpacked. Make file, no wait, make -f fuzzer mk. Yeah. Okay, it's going well. So let's do it as we usually do. Let's do reset and try to debug it. Okay, so error. Plugins, it wasn't plugins, it was plugins open, right? Yeah, I did something really weird here. It was supposed to be like this. Okay. Okay, warning, unused parameter, unused parameter. So we can just remove this. Then we, oh wait, that's C++. So in C we can, let's do it like this, define unused void, and let's do unused data, unused count. Okay. It looks really weird, but it's more like readable than anything else. And casting something to void, well, it references it, but it doesn't do anything apart from that, at least in C. I don't think it does anything in C++ ever. Okay, on 31 I need, why is it complaining? In extern C, we are already in the C language, so we don't need that. That would be for the symbol resolution, but we do not care. uint8 is not defined, that's because it's in stdint.h, and we did not include that header. Now it's included. Yeah. So this is what I said that the compiler will complain about, so okay. I don't think we care too much about thread safety. And keyword here is think. I don't think we care about thread safety. So if if not initialized, I really dislike this. Let's do it. If not initialized, then call this and actually set initialize to this. Now we actually should like set initialize to true ourselves. And now the return value is not needed, so I'm going to change it to void and remove this. Yeah, I know this is fuzzing harness and I don't have to do any code cleanups when I do changes, but let's just go with it. Okay. Now, this is funny. Expression result unused. Okay, this is funny. Windows Edge is not found in plugins, so we might actually have to mock out plugins. I'm actually going to copy like cp plugins.c and create a mock plugins file. Okay, and I'm going to link here the mock plugins files instead, and I'm going to mock it out, as in actually remove parts of the things. I'm going to remove this because it's complaining about this, but since it's complaining about Windows, it will start complaining about all the Win API functions which are used. For example, these are plugins, so you will find load library and we will find get proc address. So load library, yeah, it's here. We have to do something about it. Let's just put, I don't know, null here. And we have to do the same thing with getProc address, which is here, which is quite funny. What does it even do? That's a funny line. It's totally not readable. Yeah, it actually, like, this gets a function and this calls it immediately. We are not going to call this function at all. Then, yeah, you know what? I do not think I care about most of this. So I care about some parts which allocate the plugin info and then do the section name setup. Then they create the linked list, the commands. I need these. And then I think that's actually all I need now for this. Yeah, actually adding plugins on Linux, which are Windows plugins, is going to be fun, but we should be able to do it. But right now I'm just going to comment it out. If 0, and I want to comment it out until, yeah, I guess here. And if, okay, this is one of the, like, if you have multi-line comments like this already, so this if 0 and if is the best way to comment something out and see. And I'm pretty sure in close we will have a free library. We cannot call that because it is a Windows API function. And I think this should be it. All the other code should be fine. So yeah, let's do this, and it might fail really hard. It says there, okay, well, H instance is still somewhere here, H instance. You know what we can do? We can do type def H instance. That's actually, let's make it a void pointer. I think void pointer should be fine. Again, it's not the code which is going to be called, but okay, we just have warnings. Unused results, implicit declaration of malloc. We might want to address that actually by including stdlib.h. Actually, like, I think on Windows malloc is here and I think on Linux is here, or it's like depends on the C version, but malloc is usually in one of these two files, so it seems on Linux it's actually not in the other one. We have unused variables, so let's do, I actually don't care about these warnings right now. So I will go to my makefile, and in my makefile I will actually say no unused variables and no unused values. I do not care about that. No unused values. That's NP. I wanted NO. Okay, here we go. Let's try. Okay. There's a question. It's not live. Yes, it is live. Hi, Albert. Okay. So, and unused variable. I do not care about unused variable anyway. Oh, wait. I think I'm missing a dash here. It just doesn't like me. Oh, no, I know. I know. Now. The order was incorrect. Perfect. Now it works. Now, jump over blank. What is jump over blank and where can I find it? grep jump over blank. I can find it. No, it's being called in. You know what? I'm just going to grep through C files. And that would be string_ext. Yeah, string_ext, which we also need to link with this code. Okay. No. I want to, recompile it. And now it's missing, because the names of this API is actually different on Windows and on Linux. On Windows is, as you can see, _str ni cmp, n being here for number, I like that you can actually pass how large the string is, and I being for case insensitive, like insensitive, meaning lower and lower case and uppercase is the same for the sake of the comparison. And on Linux, that would be case CMP, so a little different naming, and we have to use this. And to actually do this, we can, to use a different function, you can either patch it in the code, or we can do something nasty. Let's do something nasty. So nicmp is going to be defined as this -d is the same as like how to define something and something, right? So like in our case, we want it to be equal to n case CMP. So we basically written something like this: n CMP, n case CMP. And the other thing is we want the same thing but without this. Yeah. And okay, it works. Now I'm actually going to compile. No, I'm going to run it, I guess, but I'm somewhat afraid it will crash right away, and I would prefer it not to crash right away. And I also need basically some stuff to fuzz. So as far as stuff to fuzz goes, I'm going to create a directory called stuff to fuzz. No, maybe goes to, yeah, well, corpus. I'm already using corpus samples. I'm going to use samples in that case, and I'm going to put at least one GoSu file to it, maybe two GoSu files. So it's samples, and I've put two files there, and this is like the language which we saw last week. And I'm going to give this as input, so it will actually be able to mutate. It might be a little bit too complicated, but we are again fuzzing the parser, so that's fine. Let's leave it, and now we might want to run it, and I never remember how to run it. Oh, I know. If I give it an argument which is not related to the directory where the corpus is stored, it will run that corpus. So yeah, samples, and let's run on index GoSu, and let's see what happens. So it ran it. This is, by the way, a typical, this is output of the lib fuzzer, and this is output of a sanitizer, in this case leak sanitizer. Leak sanitizer decided that we allocated some memory, but we never freed it. And the question here would be, which memory is this? And it actually, yeah, we can ignore the leaks or we can fix it. So let's ignore the leaks for now. It will eat a lot of memory, but yeah, like 32 bytes and one allocation, I do not care too much about it. So let's ignore it. Okay, so if, oh, wait. No, I do not pass it this way. I do export asan options equals this. Yeah. Okay. And yeah, okay. It actually ran, it executed, and it finished correctly without crashing, which is a really nice sign. So now we can actually try to run it. And if I run it like this, it crashes because of reasons. Oh no, it actually found a bug already. Why did it find a bug already? It's a stack buffer overflow at this address. And yeah, it says that memory access overflows this CMD variable, which is okay. Well, it might already be a real crash. Let's see at this crash test case. Is it an empty test case? No, it is not an empty test case. It actually already discovered, because I didn't even pass the corpus, so it just grabs random data. and it already discovered that this thing, followed with some other thing, causes it to crash, which is quite funny, but it's not unexpected. So we can try to rerun it just on that one file, and that would be crash and yeah, and it crashes on this. So what we have to do is, what I don't like is that it doesn't actually show as the proper names here. There was a way to do it. How did you symbol ASON symbolizer path? How do there was an ASON option to set it? Asian, not Asian, ASON. No longer work. Okay. So whatever. Okay. So I'm going to export. Basically, it takes a application which is able to get a binary, get the address, and translate the address into a meaningful function plus line, ideally. So I'm going to export this, which address to line. It's not the usual one, but it should work. So let's see if it works. Yeah, it works. We got, yeah, instead of like just the file path and the, the offset, we actually got proper name of the function and the path where the bug is. So it says that the bug is on this line, on execute on 133. Let us take a look what is in that file. What kind of bug did we discover? So there's a question, why not use a RAM disk or shared memory for fuzzing? It's a really good question, and if I would care about speed, I might go that way. I might actually go that way. On the other hand, operating system is modern operating systems are quite nice with actually keeping frequently used files in the cache, like and actually the RAM disk, well, RAM of the file system driver. So I wouldn't even have to do that. That being said, I do not need speed, as you can see. I just ran it for like a fraction of a second and it already found a crash. So yeah. Anyway, let's look at. Let us look at the code, which is line 143 here. Okay, so it is a buffer overflow, a stack buffer overflow. There's a stack, it's a write the size of 1. Well, yeah, this is trying to actually write the end of line somewhere. Now, the question is why? And it says that it actually overflows the something by 96 bytes. So our question would be why TMP might be going far enough. Okay, this is basically, this might be a off by 1 bug. So it might actually go pretty far, and then yeah, let's read the code. We start here, and TMP is set to CMD name. What is CMD name? I don't know. Sorry, well, no, seriously, what is CMD name? It's this buffer. So it's being set at the beginning of this buffer with the beginning of this buffer. And where is jump over blank out buffer, parser out buffer. Get rid of, why is it out buffer? Is it output? Oh, wait, what am I looking at? I was thinking about, oh, but I'm looking at this, but it seems to be something else. So what is this function? What does it do, or is it called? Okay, it's being called here. What is, this is the parse. Yeah, this is our function. So that's cool. Then it goes here, blah, 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 and then it goes to execute. Parse the command. So, okay, it has parsed one command, and after parsing that command, it actually goes to this. Sorry, I think I have to understand this code a little better. Is it just one line? Like if I look at this, right? Does it call something with one line, each line, or does it just grab everything and parses it and then executes the execute as many times as it takes? Is the execute even within this loop? How many indentations do we have here? The parsing loop, 1, 2, no, only 2. Yeah, only 2. So if we look here, the indentation is way bigger. So this is inside the loop. Okay, so it executes, it's like this. For, I don't know, like for as long as it takes, n being the length of data. So until I is lower than n, this already looks like trouble, by the way. Like, yeah. Yeah, I guess like a proper parser would not do something like this because, or maybe it's a, yeah, my problem with this is that I is actually iterated in multiple places. So we have I++ here, and it's checked against the limit, right? But here, for example, we add I+2, and we have a check whether I is now, after this increment, is it larger or equal to n? And if it's so, then return. But due to this, we actually have to remember each time to to actually like do this check. If we forget this check once, that's already a vulnerability probably, or at least a bug. So what you usually do is, instead of direct accessing a buffer, you create basically a wrapper class around, or a wrapper object around this, and you create like a stream, and you work on it like a stream of data, which means you have probably some method or some function like get character, which gets the next character from this buffer, and like, I don't know, like signals and exceptions when you run out of characters, or does nothing when you run out of characters, or just like throws some kind of error. And you usually also need like pick character, like pick the next character before actually fetching it from the stream. And because this way, when you actually like call this function getChar, and this function getChar is supposed to do the boundary check in itself, then if this is your only interface to the stream, there is no way you can forget this. You can forget this check anywhere, and if you don't forget it, then you do not have vulnerabilities. That's basically the idea, at least this kind of vulnerabilities. So this construct here and this way which is written, it's not a problem by itself, but it points that there might be this specific type of vulnerability where the programmer just forgot to do this check once or twice. So yeah, let's see. We basically check if the data begins with a triangle bracket, then we check, yeah, if there's an at, and if so. And if so, we check if we have something in the output buffer. If so, we call the function for it. Otherwise, we jump over this tag. So we jump over this and we jump over this. And we can actually take a look at our crash file for the sake of our thinking about it. So again, our crash file was like this. Let's move it somewhere here. So as you can see, yeah, we jump over this and we are now at this character, which is 80. And we copy the stuff until end of data or end of command tag. So until the end of data, which is n, which is like 4 in this case, we check if it's not the ending triangle bracket, and I'm not sure what this is. This is some flag. It's set to 0. So okay, so it's okay. Oh, its value is probably for escaping strings. So yeah, we do not go here. Instead, did we find this? No, we found 80. So we do not go here. Did we find a backslash for escaping data? We did not. Did we find a new line? We did not. So we just put the data here. So we put like this 80 character yeah, this like 80, and then we put the 3C, which is the opening bracket again. And we do not look for the opening bracket anywhere here, so that's fine. So we copied the 4 bytes of data, and now we actually exit the loop due to this condition. So yeah, I guess there are like multiple breaks, but we actually exit the loop due to this condition. So we exited the loop, and where were we, by the way, writing the data? We're writing the data to this where. And this where is pointed to, where is it pointed to? To output buffer. That's pretty weird. Yeah, so this is pointed to some output buffer. What is this output buffer? It's just a character, and okay, and we allocate buffer size of data, where buffer size is 64 kilobytes because 64 kilobytes are obviously enough for everyone. So let's go to line 320 again. And now we okay, so it's set to that buffer apparently. So we are copying the data into that buffer. So that buffer was allocated with malloc, right? Yeah, it's allocated with malloc. And where is it initialized? As in, if you allocate something with malloc, it already has some data in it. It's not zeros, it already has some data in it. And yeah, there is no memset anywhere near it. So we have basically a buffer of uninitialized data. Okay, that's great. And now, if we look at the code again, where were we? We were in this parse, no, not execute, in parse. Open. Okay, so we copied the data, and we never reached this, which means that we never execute this code. So we never terminate this data which we copied with a null byte, because I guess the programmer, old me, well, young me, expected the code to always be proper, therefore there should always be the closing triangle bracket at the end, and therefore this should be always, the buffer should be always terminated with a null byte. And that is not the case if we leave the for loop due to this condition, because after this for loop, there is no, this is the rest of the code which is here. So yeah, and then we call this script parser execute on a buffer which is uninitialized, which has no null byte in it that we know of. It might have, you know, some uninitialized bytes which are null bytes actually, but not where we actually put it, because we didn't put it there. And okay, and it calls parser and it calls output. So let's look at the execute now. We do have to understand this code really well to be able to triage the bug, to be able to analyze the bug. Okay, so we go here. We jump over blank space, but there is no blank space. This is basically jump over white spaces, like trim. If there is nothing, if it's the end of a string actually as a null pointer, then just return. Yeah, copy command name until this, but again, there might be no, the buffer is uninitialized. There are no zeros there. So we enter this loop. It looks for a space or a tab or just itself. Yeah, sorry, no buffer overflow. Well, it's quite funny, right? Quite ironic that we are analyzing this code because we just discovered a buffer overflow and the command says no buffer overflow. Yeah, it's not here. And this is again not a good code construction because yeah, the overflow is here just when I leave the loop. So even if it copies 64 bytes and then it exits and then it still writes into the buffer. So that's a buffer overflow, regardless of what the comment says. That's really ironic. So yeah, oh well, you live, you learn, right? So we go to the end of a buffer, like temp is incremented 64 times, and then wait, that's actually like that's actually a mistake anyway, because if we use this like jump over, if you have like 20 spaces at the beginning, but you won't have 20 spaces, not in this case, but there might be a case where you have like still spaces at the beginning and then something, and the I would start counting from the after the spaces. So 64 bytes after the spaces would be more than the buffer has the size of, but this is actually also called the function before, so that's fine. But yeah, yeah, the best supervisor says, yeah, like that. The comment says no buffer overflow, so there is no buffer overflow. I guess the compiler didn't read that comment. So that's actually a real bug. And is this bug exploitable? Might be. This is really case dependent, but because the buffer is never cleared, we actually control the content of a buffer. So we could have a line before that, which is actually 64 bytes long, or even like this line can be 64 bytes long, it doesn't matter. And then yeah, it would always write the 0 after the buffer. So how to fix it properly? We can add the new line. Yeah, I think even if we would add the new line, not the new line, the null terminator in the code, we still would not. We have to do it anyway. We have to, yeah. So this is the important thing about fuzzing, that if you find a bug which is potentially will always show up when fuzzing, it will block reaching the fuzzer, because the fuzzer always exits at the first bug. It will block the fuzzer from reaching any other bugs. So what you have to do as a vulnerability researcher, you have to basically take this bug, analyze it, write it down, like create a test case, write a report down, and then fix it in the code. So I'm going to fix it, because until I fix it, I'm not going to be able to continue fuzzing, basically. And to fix it, I need to go to script_parser.c. Here we go. And how do I fix it? Well, first of all, I'm going to probably here, I'm going to initialize this buffer, so memset. And this isn't the only place I need to add this. 0 buffer size. Okay, so this is the one place. Now, the question is, so this is execute. I don't want to look at execute now. I want to go here. Yeah, here. If we set where to the beginning of the output buffer, and then, yeah, so this is just the initialization. I probably want to set it here as well. So this will be parser. We set it to the beginning. Then we go into this loop. If we have to output somewhere, this is another place where I have to reset the buffer. And return to normal mode, parser, yeah, and I need to set it here as well. Okay, if outsize, then call it. Okay. Without buff, outsize. I could also, I guess, reset it here. Now, this is quite weird. No, that's, wait, no, that's weird. How does it? I'm wondering, what would happen if, because I write to where here, and I write the data of I here, and I increase the outsize. Is this a buffer overflow? No, I mean seriously, because my loop goes as long as there is data, and there is no other. And let's assume I never enter this tag. And if I don't enter the tag, then I write data and I increase the pointer. And the pointer points to a buffer, which is again only buffer size. Oh, okay, but the buffer size is 64K. What's the buffer size? Yeah, it's 64K. But the maximum input file size is 256. Because and we actually saw it in the main file, I believe. If we go here, there was this pbuff thing, right? Yeah, and parse size. So this is a buffer overflow. Yeah, let's just check it, because why not? So if we let's create a file. The file is going to be called A, because that's always the great name for a file. And I'm going to fill this file with A's. And there will be 70,000 of these A's. So this is... I'm looking here if you're wondering. So this is 10,000 and I said 70,000. So this is 70,000 of A's. And it will read it here, and then it should buffer overflow there. So, okay. And now I'm going to just run this on my A file. Boom, crash. And it's a heap buffer overflow. Yes, and I overwritten stuff. 1 byte at this address, which is, sorry, what is it? 379. Yeah, which is exactly where I pointed you. So yeah, this is a buffer overflow. That's another thing which... No, actually, libfuzzer might not be able to find this because libfuzzer doesn't like large files. So yeah, libfuzzer would not probably find this bug, but we found another buffer overflow, which honestly, I don't know how I overlooked it when I was coding it. So yeah, well, oh well, this just shows you how careful you have to actually be. So, but we were actually, when I was looking at this code, I didn't want to exploit it. What I wanted to do is I wanted to fix the bug, which would be, okay, where is... No, I don't need to do anything else, I think. Apart from actually like making sure that this is small enough, because I'm already setting the whole buffer to zeros here. This is, by the way, like super slow, so you might normally not want to fix it like this. Okay. This is data. This is break. Yeah. I don't want to... Here. Is this the only place where the data is? No, this is the place where the data is actually being also written to. At this point, we are sure that we are within the limit. But if I is actually equal to n minus 1, and I do hope n... So actually, then let's do it like this. Yeah. And yeah, if I plus 1 is equal to... So we are at the end of the data. Then actually override this. This is really bad patching, by the way, what I'm doing right now. And this, we might actually want to do something else. We might want to do this. No, wait, we should have this in one place. We should have this at the beginning. Yeah, if we are at the end of data, then we actually set where to a null pointer and we break. This is the proper way to set it, because if I would set it after the loop, I would do an off by 1. So, and this way it should be fine. Because I never write 2 characters. Do I write 2 characters anywhere? No, I write 1 character here, and I do write a 2nd character here. How is that happening? Oh, thank you for the donation, Dariusz. Darius says, I love your comment. I didn't want to exploit, I wanted to fix it. Yeah, well, oh my. That's the curse of being, I guess, a vulnerability researcher. You sometimes don't want to find vulnerabilities, but you still spot them. Yeah, thank you for the donation. Perfect. So, yeah, let's look at this. I'm actually... Why is there no continue here? This is what I'm worried about. Because this is an escape, right? So data is equal, we found a backslash to escape data. And we have this isValue is set. So we are like in a string. IsValue, yeah. If isValue is set, we are in a string. So we put this data verbatim here and we increase it. And then we copy data to the buffer again. And we again increase it. Why? This doesn't make any sense. I think that's a bug. Let's do continue here. And actually, let's... No, wait. We are at the... It's copying... Oh, no, wait. So... I do not understand this code. What was I thinking here? Well, okay, if we add at the end of a buffer, we'll never reach this code anyway, because we will jump out of the loop earlier. If we might be at the end of a loop in this case, like after this iteration. And if that is the case, we do not want to continue. So yeah, actually I'm going to do... This is really bad patching. This code should be rewritten. It shouldn't be patched. It should be rewritten from scratch and like properly this time. So if this is I+1 is equal to n, I'm just going to continue, because this way, this is like a go-to basically to the beginning of a loop, where at the beginning of a loop, I'm going to check this, like fall into here, end it, and yeah, that's fine. So this is really bad patching, but it will work for the... I'm patching here just not to make it secure. I'm patching here to make our fuzzer run longer. Okay, this is I++, and we go there. This is fine. Yeah, I do not understand that part of the code, but that's fine. Let's see now. Let's recompile it. So make... And let's try to run it with a crash. Yeah, it didn't crash. Now, this is the old crash, which is great. The new crash will still crash like the one I found manually. So let's run the fuzzer again. So, yeah. Okay, so the fuzzer is running. And that didn't find any bugs yet. Okay, and it found a bug. Rao says, won't the increment happen on the continue thus? Oh. You might, yeah, you're right, Rao. Rao says that this continue will cause another increment here of the I++ in the for loop, which is here, which will make it actually, oh my. Yeah, you are completely right. Well spotted, Rao, well spotted, really. So I'm going to ignore the bug for now, because it might have actually hit this bug again. So if that's the case, then do where equals 0. Let's do it properly. And we do a break. Okay. So I'm going to recompile it. I'm not going to look at that crash, because that crash might be related to my incorrect fix. And yeah. Can the fuzzer save the test case and then continue? Not libfuzzer, but what you would normally do, you can like just, you know, do while true do this done, and this would run the fuzzer indefinitely. Other fuzzers like AFL and large fuzzing systems do have this automated, but in this case it just goes until the first crash actually. So okay, it found a bug. What kind of a bug it is? We still have a couple of minutes, so let's look at this. It's a stack-based buffer overflow on line 165. Let's go to 165, which is our favorite line. Let's look at what kind of crash happened in this case. And in this case, our file looks like this. Okay, so this is related, as you can see the size, you do not see the size clearly here, but the size is 37 bytes. And we have a string which is, I guess, pretty long. It starts here, so that's like, what, 12 characters, another 16 characters here, and some more characters here, so that's at least 33 characters. Well, at least that's exactly 33 characters. And I'm pretty sure we saw a buffer here, which was only 32 bits, so again we overflow a buffer because whatever we have is larger than 32 bits, so we break and we still overwrite this, which is wrong. This should be 31. And then we break and then we go here, so this is an off by 1 error. I'm not sure if it's actually exploitable. Here, I think it's the same thing actually, 256. Yeah, probably one of these buffers is... Yeah, this mistake is like all around. I break and then I do this. This is wrong. This should be -1 everywhere. And so I'm just going to like patch it like this. I'm not sure about this. I'm going to leave it. I'm going to patch this. I'm basically just decreasing the buffers. And here, no buffer overflow. If j is otherwise something. If it's less than 30, yeah, let's do it like this. It might change a little the logic of the code, but whatever. Okay, let's run it again, and let's see if we actually... Rao says, just grep for comment, no buffer overflow. That is so accurate. Yeah, I see like Mugundach. Again, sorry for butchering your name. Mugundach says also that I should look for the same thing. That's actually a really fair point. Like, grepping for things like security, especially to-do security, can sometimes yield really nice results when somebody like thought about security, but like there were other important things to do first, so they did a to-do node, like to-do, like implement some security check here, and then you just go and you're like fat and happy and just grab every vulnerability which you find. Let me make a window a little bigger. No. Okay, it's going a little better now. So, I'm going to see if you have any questions, I guess, or any comments. Andrew says, maybe just limit the input file to 64K. Yeah, I think I should have... So it's like this. In case of this code, that might be the proper thing to do. Either increase one buffer to 256 or decrease the other buffer to 64K. In case of a proper tool like this, you do not do file limits. You parse the file as a stream and you do not do file limits, like file size limits on it. But Andrew, it's a good comment. And Ido has, sorry, I forgot to show you the questions, my bad. Here we go. They should be, well, there. Yeah. What tips can you give us from your FFmpeg fuzzing experience? Yeah, okay. So if you're asking from my FFmpeg fuzzing experience, then to answer that question, the obvious answer is use a lot of servers to fuzz on, because Ido is referring to something I did with Juru, with Mateusz Jurczyk, and at our work. So fuzzing. No. Yeah, basically this was well, 5 years ago, I guess now. And at the time of writing this, there were 1,000 bug patches in FFmpeg project itself for the vulnerabilities and bugs we reported. I think the count increased like by 500 in the next half a year anyway. So yeah, what we basically did is, long story short, we've written a really nice fuzzer and we used 2,000 cores or 2,000 servers to actually run the fuzzer. And yeah, if you have this kind of scale, fuzzing becomes really effective. Fuzzing, especially dump fuzzing, we were using a dump fuzzing at this time. It was, oh, that's not good. You might not hear the noise, but I hear a noise, which means that my water pump, my water cooler is not working correctly. Let's see if my CPU will crash. I'm actually running an application to check the sensor data as in temperature. No. Okay, I have 84 degrees on my CPU, 85, 86. I might just go. If you suddenly lose me, that means I just rebooted my machine because of my CPU failure. 92 degrees, 93 degrees, 94 degrees, 81. Okay, water pump is working again. I don't know why. I have like I don't remember which company I have, but I have a water pump on my CPU and I refilled the water last month, but it still sometimes just like jumps itself for 15 seconds and my CPU temperature goes up to almost 100. And I actually have a failsafe on the CPU on 100 degrees. That means as soon as it goes to 100 degrees, my CPU will just shut down. And like the computer fully shuts down to prevent any damage. And I guess also to prevent water from boiling. That would be really unfortunate because that would really increase the pressure. Anyway, yeah, but thankfully it usually reaches like 95 degrees and then suddenly like the pump catches water again and starts working. But this is the first time it happened on my live streams. I did add water to it, so it's not water. I'm pretty sure I correctly added water to my circuit on the cooling, which means I will have to change my cooling on my machine, which I don't like. I don't want to do it because I need to take everything apart to be able to change the main cooler, like including taking out the motherboard, and that will be painful. Yeah. Oh well. Okay, I was saying that yeah, the tip I can give you from FFmpeg fuzzing is like run it on 2,000 servers, and that will increase your fuzzing output because dump fuzzing scales really well. And I mean like dump fuzzing scales this way. As in the more machines you get the same amount of performance out of it. There are some gachas and gacha related to it, but that's the case. That's not really true anymore for coverage-based fuzzing, which is, for example, what's going on here, because for coverage-based fuzzing, it is it doesn't scale so well because you have to do corpus merges which don't scale too well. That's yeah, you can I guess write your doctor's thesis around this stuff, but that's it. I guess another tip I can give you for fuzzing is to have a good corpus of input samples. This is especially important for more complex file formats where a genetic fuzzer would not reach the given input state, given branch on its own. Also, you want to disable all kinds of checksums and checks like that, and basically encryption and probably compression as well in whatever you're fuzzing. For example, if you are fuzzing like Flash and the Flash can have both compressed and decompressed files, you probably want to fuzz only the decompressed ones. Unless you're fuzzing the compression algorithm and not Flash itself. So yeah, that's another tip, I guess. Oh, you should probably look at Mateusz Jurczyk's presentation about fuzzing. He has one where he noted a lot of stuff which we thought about and which he thought about when we were fuzzing in the last several years. So if you, let's go to his website. Yeah, Wolfgang asks if there's an air bubble inside. There's probably an air bubble inside. Or that, or like there's some other random problem. If you go to Euro's website, there is... where are his publications? Oh, sorry, it's in publications conference talks here. Yeah, effective file format fuzzing. This is from Black Hat from 3 years ago, and there's also a recording. You do want to, if you're into fuzzing, you do want to look at Euro's presentation, because Euro is one of the best people who can actually properly use a fuzzer and not just run a fuzzer, but actually properly iterate on fuzzing. So whatever he can share, it's really worth looking at, and I'm going to give you a link right now. Okay, yeah, it must be bug free, no crashes anymore. I guess this is the iteration number, so it's pretty fast. As you can see, we have already 7 million iterations, so that's something. Okay, let's not go there. I think if I have any other tips for FFM for fuzzing stuff, but yeah, like dial in next week, because next week I will also try to iterate on the fuzzing, because now we are running a fuzzer, right, and it's not finding any bugs, but we don't know how good the fuzzer is actually right now, and next week we will chat about how to check it, how to check how good our fuzzing is. And then how to iterate over it, how to, probably we'll also like try to move to another target, being now we are fuzzing the parser, but we probably want to fuzz the language implementation itself as well. So that will be happening next week. Okay, could I check with 2000 servers? No, I should not use this code on 2000 servers. Yeah, so I guess that's it for today. I don't think there are any other questions, therefore we can call it a day. I think I'm going to leave this fuzzer running for a couple of more hours just to see where we get with it. And yeah, and I think that's it. So thank you for being here today, and thank you to Foxtrot Charlie, who was my moderator today and who was helping me with the live stream. And thank you everyone for coming. I wish you happy fuzzing and happy bug hunting, and I'm going to leave you with some music and see you next week when we continue with this. So yeah, that's it. See you, have a great day, great evening, and bye bye.